Welcome mathematicians to today's video. In today's video we'll be examining linear equations, and the skill in focus will be sketching linear graphs from equations. Now this skill is pretty simple, but it's an area that a lot of students have difficulties with, so I hope you can get something from this. Let's jump straight into it. Quick recap. In order to sketch a straight line, what's the minimum number of points you need? And the answer of course is 2. If you've got 2 points, you can draw a line between them. Students learn this fact in early secondary school. However, by the time they get to senior secondary school, they've quite often forgot or not used this skill for quite some time. So here's a quick sketch and another sketch. And as you see, it only takes 2 points, 1, 2, to define this particular line. And on the other side, it only takes 2 points, 1, 2, to define this particular line as well. And that's the fundamental skill we'll be using for the next 4 examples. So these questions are coming from the VCAA exams in recent years. So the first one's from 2017. It's the Further Maths exam number 2, question 3BI. The number of female moths caught in a trap is set in a forest, and the egg density, that is eggs per square metre, in the forest are shown in the scatter plot below. So I have our scatter plot there. The equation of the least squares line is egg density equals 191 plus 31.3 times the number of female moths. And our task is to draw the graph of this least squared line on the scatter plot below. So let's look at the technique. So first of all, we want to select the 2 extreme x values on the x-axis. So that means number 10 on the far left, the minimum possible number of female moths displayed on our x-axis, and the number 60 on the far right, the maximum number of female moths. And what we want to do now is find the corresponding y values that match those extreme values of 10 and 60. So point number 1 we're examining is where there's 10 female moths. So we use the above equation, which states egg density is equal to 191 plus 31.3 times the number of female moths. And we're going to substitute in 10 for the number of female moths. You put that in your calculator, you end up with an egg density of 504. So we now have 1 point where we have an x of 10, that is the number of female moths. We end up with a y of 504, that is the egg density of 504. So we now have a coordinate that we can plot. And there it is on our scatter plot. We need to repeat this process now for the second point, where we're looking at 60 female moths. So we have our equation again. We substitute in the number of female moths as 60, and that provides an egg density of 2069. So here's our second point. So this point represents 60 female moths and an egg density of 2069. And we plot that. Point 1 from our minimum number of female moths at 10, and point 2 from our maximum number of female moths at 60. Our final step is just to use the ruler and draw a line between the 2 points. And there, that's our answer done. It's as simple as finding a coordinate for the minimum number of female moths and a coordinate for the maximum number of female moths and joining with a line. Now the VCA examiner's report. They state this question was not well answered. Many students did not realise that the scale on the horizontal axis started at 10 and not 0. Now what they mean by that is a lot of students will look at the equation and go, oh, there's the y-intercept, 191, and think they're meant to make a mark on the axis here for 191. Now that would be true if the x value was 0. But this graph is not showing an x value of 0, it's an x value of 10, so we can't simply use the y-intercept from the equation. We need to substitute 10 into the equation to calculate our coordinate. It was clear that some students did not take a ruler into the examination, so that's a point to note as well. Example number 2, 2018 Further Maths exam 2, question 3BI. It states, the yearly average traffic congestion levels in 2 cities, Melbourne and Sydney, during the period of 2008 to 2016 are shown on the scatter plot below. Now, first of all, this graph represents some data that is incomplete. An earlier section of this question required the students to finish that graph, so don't be confused by this particular from the key from this Melbourne data. The equation of the least squares line for Sydney is congestion level equals negative 2280 plus 1.15 multiplied by the year. And the task is to draw the graph of this least squared line on the scatter plot below. So Sydney data is a solid black line, so it's this particular line here that we're interested in. So let's repeat these steps again. Step number 1, select the 2 extreme x values on the x-axis. So the minimum on the far left, the maximum on the far right. Step 2, let's find the corresponding y values for this equation. So the first position is where the year is 2008. Now we're going to substitute in 2008 for the year variable. When we calculate that, we end up with a congestion level for 2008 of 29.2. And that gives us a coordinate point that we can plot on the graph. Okay, x equals 2008 and y equals 29.2. There's our first point. Repeat this now for our maximum value from 2016. So point 2, when the year was 2016, we substitute that in, and we end up with a congestion value of 38.4. So we now have our extreme right-hand side point, the coordinates of 2016 and 38.4, and we plot that. So there we go. It's a year level of 2016, and going across, that is our congestion level of 38.4. Final step is take a ruler and join. Easy. So the examiner's reports on this one. Significant number of students did not answer this question. Can you believe it? Those who answered correctly typically used a ruler and often also wrote down the coordinates of the two endpoints, that is 2008, 29.2 and 2016, 38.4. You don't have to state these coordinates, but it seems that many students who got the answer right did so. So maybe a good tip. Third example, 2020 Further Maths Exam 2, question 5a. The scatter plot below shows body density in kilograms per litre plotted against waist measurement in centimetres for 250 men. The equation of the least squares line is body density equals 1.195, take away 0.001512 multiplied by the waist measurement. And the task is to draw the graph of this least squares line on the scatter plot shown. A lot of data in this scatter plot, but again, the same simple steps are applied. Step number 1, select the two extreme x values on the x-axis. So there's our minimum, there's our maximum. Step number 2, find the corresponding y values from this equation. So we have coordinates to plot. So let's examine point 1 with a 60 centimetre waist. In our equation where we have the waist measurement, we're going to substitute 60. We now have 1.195. We're going to take away from that 0.001512 times 60. This produces a body density of 1.104. So we now have our first coordinate, a waist of 60 centimetres and a body density of 1.104. And we can plot that up on our graph. Let's find our second extreme point. Point number 2, we're looking at a waist of 130 centimetres. So we substitute that in to our equation and we find a body density of 0.998. That gives us our second coordinate. We can plot that as well. Next step, quite simply, is you take a ruler and you draw a line between the two and your task is finished. So some feedback from the VCAA examiners. They said that some students skipped this question entirely while others drew a line by eye. It is necessary to calculate appropriate points and to plot them in order to get an accurate line. Students should ensure that their line extends across the whole set of axes. That's worthwhile. So they're saying we should start on this minimum for our first coordinate and go all the way down to our maximum on the right-hand side coordinate. And most lines were drawn using a ruler. Again, a lot of students simply didn't attempt this question or alternatively made up an answer. 2021 Further Maths Exam 2, question 4a. The time series plot below shows that the winning times for both men and women in the 100-metre freestyle swim in the Olympic Games has been decreasing during the period from 1912 to 2016. And we have here an equation for the least squares line for women. It says the winning time for women is equal to 538.9 take away 0.2430 times the year. And our task again is to draw the graph for this least squared line on the scatter plot shown. You can see from the key, the women graph is represented by a square with a solid line and the men with circles and a dotted line. So the line of best fit's already been done for the men's in an earlier question, and we are asked to draw the graph of the least squares line for the women's data on this scatter plot. So let's repeat the steps. Let's examine the two extreme x values on the x-axis. There's the minimum, there's the maximum. Step 2, let's find the corresponding y values from the equation. So for point 1, at 1908, we take our equation, and where there is the term year in our equation, we replace it with the number 1908. That provides us with a corresponding winning time for the women of 75.256 seconds. So we now have a coordinate with a year of 1908 and a time of 75.256. And we can plot that on our scatter plot. So this point represents a year of 1908 and a time of 75.256. Let's repeat this now for the year 220, which is our extreme maximum or right-hand side of our x-axis. So point number 2, the year is 2020. We're going to use the same equation for the winning time of women. We substitute in for the year, the number 2020, and that provides us with a winning time for women in 2020 of 48.04 seconds. So the coordinates we've generated here is a year of 2020 and a time of 48.04 seconds. So we can plot that on our axis as well. Year of 2020 and a time of 48.04. Simple. All we do now is join a line between these 2 points. There's our line. That's the task complete, full marks. All we need is 2 points and a straight line. Some feedback from VCAA. Students who wrote the endpoints of 1908 and 75.256 and 2020 and 48.04 on the graph tended to be successful. The line needed to be positioned clearly on the graph, And the best way to achieve this would be to establish the two endpoints and connect the two using a ruler. While the writing of coordinates is not necessary to achieve this aim, it is useful. Once again, many students left this question out entirely. These questions are too simple to simply leave out. Easy marks. So, in summary, when sketching the graphs of a least square line on a scatterplot, do select two extreme values, that's the maximum and minimum on the x-axis. Do use the least squared equation to find the corresponding y values. Do plot the 2 points, that is the coordinates on your scatterplot. And do use a ruler to clearly draw the line of best fit joining the 2 points. And finally, do make sure that the lines extend across the whole set of axes. The only don't we need to be aware of is don't simply use the y-intercept from the least squared regressions as a point, unless the x-axis starts at 0. If you have enjoyed and indeed learnt something from this video, please remember to like, share, comment, and subscribe. And as always, thanks for watching.